Good afternoon or good morning for everyone. I hope everyone is hearing me correctly. I'm going to start with the presentation of virtual reality simulation for nuclear training. Just to offer a brief outline for this presentation, I'll start by considering the background. Then I will look at some difficulties and challenges we find nowadays in the nuclear sector. I will spend some time on the description of the tool and its features, and then I will move to the uses of the tools. To finalize, I will enumerate the conclusions of the presentation. So let's start with the background. TECNATOM is more than a 50-year-old company, and nowadays we can say it's a global leader in delivering advanced engineering and also a reference in the nuclear industry. TECNATOM services include many sectors, areas, and technologies. But this presentation is focused on the areas of training personnel by means of full-scope simulator, on the plant operation support, and on simulation activities, mainly for the nuclear sector. The aim of these areas has always been to contribute through technology development and the application of its services to provide the client with a qualified organization and personnel and the best resources to facilitate the operation of their facilities, ensuring improves. In order to contribute to ensure that electricity generating plants have optimally qualified operations, maintenance, engineering, and technical support personnel whose performance serves to improve safety, availability, and economic efficiency, TECNATOM provides overall training services. Particularly in the simulation area, TECNATOM has over 30 years of experience in nuclear power plant training simulators and has developed a large number of full-scope simulators for nuclear power plants worldwide. That means, until now, the way of training, our methods and methodology for training have been efficient. Nowadays, because of the apparition of the new technologies and the change of learning methods of the new generations, this training has to be adapted to them. So the solution is not to change all the lessons, but to use the new technologies as additional information that is going to provide several benefits for the nuclear training. Now, let's move to the difficulties and challenges. The first challenge I'm going to talk about is the needs of the companies. Concepts such as spending less time, acquisition of high level of knowledge, reducing mistakes, looking for data accuracy, spending less money, or adapting of the specific needs of clients are concepts with which all of us are familiarized in order to improve productivity or performance of all types of companies. Nuclear plants are not an exception, and continually they strive to improve performance, to reduce human mistakes, and reduce costs. Besides, it is well known that nuclear plants have to face with the problem of generational replacement. The average age of the workforce is 50 years, so we are looking at a significant number of retirements in the next several years. Approximately, and according to the Nuclear Energy Institute, 50% of the current global workforce is set to retire in the next 5 to 10 years. Specifically, in the United States, the Nuclear Energy Institute calculates that nearly 38% of the nuclear industry workforce will be eligible to retire the next 4 years. So, to maintain the current workforce, the industry will need to hire approximately 20,000 more workers in 4 years in order to replace the retirees and to build and operate current and new nuclear power plants. These workers carry with them extensive technical experience and in many cases plant-specific technical information from the construction period that is not included in procedures. Thus, these employees are of great value to the nuclear power plant's operating organization. What we need is a transfer of knowledge between generations, taking into account that the new generation learning methods are quite different from the previous generation, mainly because of the incorporation of modern digital technology. So, the big challenge we are facing is to improve the operation of the nuclear power plants despite the impact of generational replacement. To face the situation, we propose to combine, on one hand, the knowledge we already have, and on the other hand, new technologies that they will help not only to transfer the knowledge to new generations, but also they will help to reinforce the knowledge to workers with experience in a faster way. So, as I just said, we already have the knowledge, as our company has been working for over 40 years in training operating personnel, and for over 30 years in developing full-scope simulators. That means we already have efficient methodologies for training. But now, what we are doing is to use the virtual reality in order to reinforce our training lessons. That means that as we already have our model simulated with best estimates from Israeli codes with a high and proved precision, we have connected the simulation with our virtual reality tool, making possible to display all the parameters calculated in the code, including complex variables. And all of this with a high definition visualization. In the next slide, I'm going to explain this virtual reality tool. As an example, it is presented the application to a three-dimensional visualization of a PWR plant primary system. The application user interface is divided into two main areas. On the left, there is a control area that contains panels that allow users to manage application functionalities. On the right, we appreciate the virtual area where the virtual representation of the model is displayed. The application can be turned to full screen and the control area disappears automatically. To operate this application, the user can do it by using keyboard and mouse, gamepad, or touch screen. The main goals of this product are detailed in the next slide. The first one is to visualize the plants in 3D and in a more realistic way, and to have the ability to move around. Any displayed component can be identified as a fixed point, and the user will move the model around this point. The second goal is to be able to watch inside of the most relevant plant items in order to better understand the behavior. We have three options that allow to switch between solid and transparent plant visualization, and also to open closed solid inspection objects. The next functionality is one of the most interesting things of the tool, and it is the possibility to display parameters chromatic information supported by color interpolation to better highlight how the values propagate in the system. This option becomes active after the application has established communication to the server, and parameter list is automatically displayed. This parameter list enumerates all the variables we use in our simulation code, and so any of them can be represented. Unlike the simulator, where only some values are displayed, with this tool we can know the value of any parameter. The user will be able to select or change the variable to be represented using a dedicated menu. When a parameter is selected, its chromatic scale is presented in overview on one side of the screen for reference, and the user will be able to show this scale. The entire system appears semi-transparent, and the item cell variable values are shown as color gradients according to variable value and chromatic scale. The user will be able to represent the variable time evolution, observing item cell color change. The next use of the tool is the visualization of malfunction. At any moment of the simulation, we can visualize the state of malfunction. There is a panel in the control area where all the malfunctions are displayed with a check mark that it becomes green or red depending the malfunction is activated or not. As we saw 2 slides before, simple variables can be displayed, but also we can display complex variables. For example, the flow regime that contains different simple variables. Regime type, boil factor, water velocity, and steam velocity. The last functionality of the tool I'm going to explain is the possibility to have graphic representation. We can display a window in the slide is displayed below to follow the values of any variable, and we can display several parameters at the same time. I also want to explain how the architecture is, as it is a very simple one. It is a client-server architecture where the client is interfaced to our virtual reality tool, and it connects to the server that is interfaced to the simulation. So our virtual reality tool has the same load as the interface graphics system and the same as the full scope simulator. There can be several clients connected at the same time, and that means we may have several students learning at the same time, and each of them interacting with the application. So, after the explanation until now, I suppose all of us agree that virtual reality enables to deliver large amounts of information in a visually attractive way. Many students, and above all, students of new generations, find it easier to learn when presented with a visual explanation. Most of the students find it easier to learn, understand, and retain information if the learning experience is a pleasant one. You cannot compare, for example, to reading a paper or listen to someone explaining the components inside a model or how systems interact between them, with the possibility to have a visualization of these components or systems. So, what we have done is to add this virtual reality information to our already existing training lessons. We maintain the explanations written in paper, but now we have added a link that gives the opportunity to visualize them. The link usually can open whether the virtual reality tool, whether a recorded video. In the first case, the student can interact with the model, rotate it, zoom wherever he wants to better understand the lesson. In the second case, when the link opens a recorded video, the student can reset, backtrack, replay until he decides he has understood the lesson. It is very useful for the explanation of components, interaction between systems, to better understand and visualize how components are built. In this slide, we have another difference of using this application. On the left side, the plant is in 2D, and now our tool allows us to have a real visualization of the plant with the real dimensions of the component. We also propose this tool as a benefit for the explanation of complex variables, as we can visualize the thermohydraulic behavior inside the plant. Once we have selected the parameter and adapted the scale, it is easier to understand the state of the nuclear power plant at a glance. Besides, the user will be able to appreciate the variable time evolution of certain item cell color change. Furthermore, it is used for the explanation of incidents or accidents in nuclear power plants. For these cases, we have recorded some scenarios reproducing different situations that are explained in the record. These videos contain the visual explanations, but also they have some additional information written of the sense, and usually it is also an audio recorded. As a summary of all the uses I have just explained of our tool, I repeat that TECNATOM has already an e-learning platform where students have been doing their lessons online. These training lessons already contained components and system description, principles of operation, procedures. Now, with this powerful tool of virtual reality, the content has been reinforced, adding links to the tool where the students can play with the system, rotate them, make zoom, have a real view. And we have also added some new functionalities as the graphic representations and videos of scenarios. This updated training has already been used by the students in the initial training, and the feedback received is very positive as the students understand faster a lot of the required knowledge. The last thing, but not less important, is that this tool can be integrated with other different tools. As an example, we can connect the glass-top simulator shown in the left side of the slide. It can be useful to make the students understand the consequences of their interactions with the simulator. TECNATOM has also developed an immersive training system for field operator. You have a picture in the right side of the slide. This system is also extended by a virtual three-dimensional representation of the plant designed for the use of the field operators. In this immersive environment, field operators can move and interact as if they were in the real plant. The immersive environment fully interacts with the simulator. Actions taken by the field operator will impact in the simulation system, and actions performed in the control room will change the information visible to the field operator. So, connecting these three tools, we have obtained a real simulation of the nuclear power plant where operators in the control room and field operator can be training together. And finally, we arrive to the conclusion. First one, we propose a powerful tool that links a high-definition virtual reality with our high-precision model simulated with best estimated thermohydraulic codes. Including this tool in our training methodology makes easier the transfer of knowledge between generations, facing the problem of generational replacement we found nowadays in the nuclear power plants. Also, this tool is useful to reinforce the knowledge of the current workers. And the last conclusion can be that the 3D visualization also adds value in nuclear activities such as engineering, simulation, and maintenance. So, until now, my presentation. Now, if you have some questions.
Yes, yes, Susana. We have here two questions. The first one says like this. It says, can we actually upload different situations or scenarios to the system, or we depend on what is available in the system? What I guess is like this delegate wants to know if they can actually, as let's say, training managers can upload different situations to the, let's say, the system itself, or we actually depend on what you guys are able to create or upload in the simulator.
Okay, so as our tool is connected to the simulator, all the situations we can reproduce in the simulator, we can record it in our tool.
And do you guys, for example, provide a training, let's say, to engineers on institutions, actually to do some programming and make them like able to create their own situations for training?
So we have already developed some specific thermohydraulic lessons to students that are taking their training here in TECNATOM.
Okay, and the other question.
But as I say, sorry.
Yeah, no. Okay,
sorry?
so I'm going ahead with the other question, and it says, is this simulation tool able to provide, let's say, solutions to a real accident situation?
That it depends more on the scope of the full scope simulator.
Okay. So actually the main target on the solution is, let's say, universities, nuclear power plants. Basically they want to know exactly what is the let's say the most efficient target for the tool.
So now is the basic training. We think this tool is very useful for understand the behavior of thermohydraulic. So, and to better understand the phenomenology inside the power plant.
Okay, and then I guess we have the last question here, and it says like, in the example of the LOCA, can the triggered event be located in more than one location?
In all of them.
In all of them. Okay. We actually had a few questions more. People got interested right now.
Okay.
Next one. It says like, a transient is very quick. How can the visualization help if the event is over in a matter of seconds? For example, a steam line break. A steam line break.
Okay. So we have the possibility to make to run in a slow time in the simulator, and then as it is connected with the tool, when the simulator is in a slow time, we are going to have the reproduction of the situation in a slow time.
Okay.